So tonight, it's the same one we had last week. Although I corrected the spelling on the file, I had an extra T in there. That's the kind of person I am. I give you more. I give you extra. I give extra letters. Other stingy teachers that don't give you extra stuff. All right, so this is, and this is all we're doing tonight, hopefully. Hopefully we'll get through it, because it's actually quite a bit to it. Okay. Let's see here. So, again, it's the same one as last week, or it's in the your email, and it's also in Blackboard. It's this thing. Okay, and I'm going to switch. I can use my calculator. All right. So we kind of have a kind of an introduction here. And the next thing we're going to do is find the my spacing got messed up. Find the sample size. And hopefully this is monetary sampling tables and formulas are on the back of this handout. This will be the last page. And I think what I'm going to do for on the screen here, I'm going to copy that into another. Just so I can, hopefully I'll have them both up on the same, at the same time. So this is the last page. And this is our formula for the sample size. And it looks a little intimidating, but it's not terrible once we get used to using it. So I'm going to copy that over into, nope, not there. Nope, not there. Hey, you don't have to do this. I'm just putting it in the same, so it's in the same there. In the future, I probably should just put that there. That would be helpful. Okay, so this is the formula for our sample size. And right away, the one thing that you'll notice about the calculations, though, that is nice is there is no standard deviation. You don't need to find the standard deviation to do this method. In the classical sampling, you'd have to find an estimate of the standard deviation to pick a sample size. You do not need that in this one. And I think I told you because it's the sample is, each dollar is a sample, so it's one. There is no standard deviation. It's simply a counting number. Okay, so we need to find some things here to get our table. Let me pull this one up. I'm going to every time I do this, I forget how I did it, but it is, I want to hide the ribbon. Minimize the ribbon. There we go. Okay, so I am going to make this one small. Hopefully we can see it on the screen. Okay. I'll do the same thing here. Okay, so I'm going to put in start doing my sample size here. Okay, so the first thing we want is the total population. I should say the total book value of the population. This is book's formula. So this would be the total population of the book value is 1,600,000. So we're going to take that. Times reliability factor. And say, what's reliability factor? Fair question. Down here. So on that last page, we have probably a reliability factor for misstatements and overstatements. And this is the table. So here's reliability factors. Now you'll notice that for each one, there is a number of amounts, right? So which one do we use? If you go down to the bottom of that table, it says row 0 is used for the reliability factor for sample size, which is what we're doing, and basic precision, which we haven't talked about yet. So sample size, you use row 0. So let's see here. We're doing this at 5%. Oh, I lost all my stuff. Oh, here we go. So 5%, so coming down here. Start out row 0. Wow. So start at row 0. Uh, 5%. Oops, it's 3. So that is going to be our reliability factor. So that's going to be the numerator in this. Underneath, we need our tolerable misstatement. And again, that's for whatever account this is. It doesn't say what kind of account it is. Sorry about that. Okay, so tolerable misstatement is 120,000. Minus the expected misstatement is 5,000. Again, if this is confusing, it should be. This is the first time we've ever seen this. 5,000 times an expansion factor. So reliability factor is on the top. That's this one. If you go to that table, the one underneath it, wait a minute. I think I can do it. See something. Oops. I need this. Bring this down with me. Carrying it down. Okay. So the expansion factors, the nice thing about that is there's only one. So at 5%, That's it. There's nothing else on it. So the expansion factor is another one we need. That is 1.6. Okay, so this is our sample size. This is what we're going to use to get our sample size. Okay, so this will I'm sorry. So 1.6 million times 3. Yeah, turn your calculator on. I'll write that down. 1,600,000 times 3.
48 million. Yeah.
And okay, underneath here, 120,000 minus that. So let's take
This is 8,000. The 5,000 times 1.6.
this is 8. Okay, so there's 8,000.
Yeah.
So this
And then the subtraction of that will be 112. Like, so 112,000, sorry.
okay. Thank you.
Mm-hmm.
So this is
42 point something. 42.85. Or do you want us to round?
yeah, we're gonna round them, and I'm gonna talk about that for a second here. So 42.85.
Mhm.
Oops, that is wrong. My spacing is wrong too. Okay. So obviously this is the sample size, so we can't take a 0.85 of an item. So in this case, we're going to round it up. Now the true formula is to round it to the nearest whole number. However, I would say always round it up, just because part of the reason we're doing this is that if you go into court, you want to say, if there's a problem, you say, oh, no, we did our work. And you don't want to have to go in there and say we rounded down on something. So I would just say always round it up. But the true formula is you round it to the nearest whole number. So in this case, it'll be 43. So this is going to be the sample size. Let's make it down. Now the interval is we're going to take 43 items, and we're going to test the population of 1.6 million. Copy that. Oopsie daisy. By the way, these formulas are also given. This one's also given down here. Try to put that one at the bottom of the page here. The interval. Okay, let me copy that. Okay, now let me do that. I'll send it. How about that? Okay, so equals the book value divided by the sample size. Of 42. No,
43.
43. It's so annoying. I did something. Okay, so that would equal
37,209.3023. So we could leave it at 37,209.
probably yeah, but 43. Yeah, so that would be the interval that you'd have. So the first one that would cross 7, 9. And yeah, you can definitely round that off. Probably the nearest dollar would probably and if you did take a larger sample size, it would not hurt anything. So this is the interval. So you take 43 items, and the interval is just taking the entire population book value, 1.6 million, and dividing it by the number of items in the sample. Now, going through this seems a little cumbersome, but the reality is that this is much quicker than trying to do it for classical sampling. It's much less work to do to find a sample size for this than it is for. I knew there was something kooky going on. It's all my stuff I have. Not sure why I did that. All right, go ahead and try this next one. And I will do it at the same time, but you guys see, so see if you can find this. Now be careful on this one because this is at 10%. So they're deciding at the, they'll be 90% sure or whatever. So when it comes to these tables down here, you're going to be using the 10% ones rather than the 5%. So it matters what, you can see that they change. It matters which, what your risk of incorrect acceptance. Something wrong. Get it on the same page. I know. I don't need that stuff anymore. There we go. Now it looks terrible down here. All right. Let's see. Yeah, this one I would probably round up. Just that would just be me being overly cautious and or whatever it is. And you know it's one item, and it might save you a headache later on. So I would say rounded up. Now, if you took the 113, that's fine. That's actually is the 113 would actually be according to the plan. That would be, you know, according to this sampling technique, is what you should take. Again, I would just always round up. It's me being paranoid. So it'll be close. It'll be about the same. It won't be too much different here, but this will be. Again, if you use one. If you use 113, it's absolutely fine. It'll be close to the same. 21. I'll put it up both ways. What in the world? Why are these margins so big? Wow, right there. Giant margin. Okay, so if you do use 113, it would look like this. 22, 1, 2, 3. Nine. Nice. So again, so if you round it to the nearest one, it'd be that. If you rounded it up, it would be this one. And notice that they are, so the number of items in your sample is going to make a difference in your interval. And if you recall from the previous, what we did last week, that interval is important because that tells us which ones to pick. Now, this is one of the things that is, and we'll find out a little bit later, that is a drawback to this method that's different than the classical sampling, and that is if there's a problem. If there's a problem in planetary unit sampling, well, let me go back to classical sampling. If there's a problem in classical sampling, now remember, if you're testing at the 95% level, that means 5% of the time you're going to get it wrong. So 1 out of 20. Not unusual for that to happen. Okay, and 1 out of 20 times of doing sampling. So if something does come out and do wrong, now in classical sampling, you go, okay, well, we'll go grab another sample. We'll expand the sample, to a larger sample, and that way, we can become more sure of our answer by expanding the sample. So instead of going at the 95% level, let's bump it up to the 99% level. Go grab some more items, throw them in. You can't really do that with monetary unit sampling. If there's a problem, because notice if you went and grabbed more items, it's going to change the interval. If you change that interval, you're going to change the items that you pick. So it's not going to be an easy way to expand the sample. So a lot of times what you'll do is if you do run into a problem with monetary unit sampling, you may just go ahead and switch over to classical sampling, because that way you can control better the outcome, your desired amount of assurance. Let me stop sharing or start sharing. So, is there a question on that? So, part of the problem is that these are all tied together. Number of units, the items that you pick, all those are. I mean, the nice thing is that they're automatically picked for you. Another, thing about this is that you don't have to grab a random number table or whatever. You just do the cumulative total. Put it in an Excel sheet, run the cumulative total on it, and whatever one crosses 21,929, that's when you pick. The next one that crosses 20, whatever it is, 20 or 43,000 something, you pick that one, and so on and so forth. So it picks the sample for you. Okay, so let's see here. Let's minimize that. Okay. I think I talked about this before, but I'm not 100% sure. That if a couple of things to go into this. Yeah, I'll go ahead and talk about it. Actually, these two probably should go together. Okay, incremental allowance. Incremental allowance is some additional error that can come into play if the book value of the item is less than the interval. And what I mean by that is like down here, this book value is less than the interval. Interval is 40,000, the book value is 20,000. that this item means that there could be more things misstated in that $40,000 interval than just this one item, because there's more dollars left in that interval. There's still another 20,000 left that is not this item, it's something else. So because of that, there might be additional error in it. And actually, so it's sort of like this, that if you find an error, that means that an error can occur. But second of all, it means if the item does not take up the entire interval, it means that there could be more things wrong. Now, all errors are not equal. So a little error is dealt with less harshly than a large error. There's a difference between having an error of $10 and an error of $10,000. So there's going to be what they call we're going to call it an incremental allowance. We'll talk more about this on the next part of it. But it has to do with, so there's two things that happen, and that is that the error has occurred and the size of it matters. A small error is going to have less of an impact than a large error. All right. So that's kind of the idea behind what they call incremental allowance. For right now, just know that it makes it a little more iffy. We'll say, your sample, because it's going to say, okay, there's possibility errors can happen, and it matters how big those errors are. The bigger those errors are, the bigger the problem. Small errors, small problem. Big errors, big problem. Okay. I think I talked about this. I could be wrong, but monetary unit sampling is only used to detect overstatements. Understatements are ignored. And we talked about this a little bit up here, that if it's not good at finding understatements. For example, if this $800 book value, if this was 0, what would be the chances of it being picked? 0. It's never going to cross the line. So it's not good at understatements. It's not used for that at all. So when we find an understatement, we ignore it. So when we find an understatement, we ignore. Hey, I want my thing back here. Oops. So understatements, it's kind of like fishing. You go fishing and you catch a boot. You're not trying to catch a boot, so you throw the boot. No, you probably don't throw the boot back in. That'd be littering. But anyway, you're not happy. You're going to, So you're only looking for overstatements. Are the only things that you're looking for. So understatements, you ignore them. Now, this kind of goes back to that incremental allowance. I should put these together. I think I must have taken this out of the book or something. But anyway, if the item covers an entire interval, for instance, this one, the book value is 44,000, the interval is 40,000. There's 100% chance this is going to get picked, right? Because this is going to cross a 40,000 interval. It might cross 2 of them even, but there's 100% chance it's going to get picked. However, that interval could not be any worse. There's not going to be any more incremental allowance. Why? It couldn't be any worse than it already is. It covers the entire interval. there's not going to be any additional allowance. Okay. So let's take a look and see how this works. Okay, we got a book value of this, and these are the items that we found that might have problems. Okay, and the way I got this set up is intentional. So audit by book, we did that before last class, I think. So, and by the way, if you ever, it's alphabetical, audit over book. So audit value divided by book. Times that, that'll give us a projected value. Divided by 20,000. So 0.7 times 40,000. So 28,000. So the projected value is 28,000. The projected misstatement is 12,000. Okay, and is this included incremental allowance? If the book value is less than the interval, and it is, it will be included because there could be more things wrong in there. And again, I know I haven't told you how we're going to do this incremental allowance, so hold off on that for a minute. There's a lot to this method. It actually is easier than the other methods, but it doesn't seem that way when you first go through it. Okay, coming down here, kind of the same thing. $2,400 divided by 3,000. $32,000. So, what would that be? 8,000. And is the 3,000 less than the 40,000? Yes, it's less. So it'll be an incremental allowance. Yes. This one is a little bit of a tricky one, and it's I don't like the way this is shown in the books so much. Yeah, in the books they'll tell you if something is 0 and it you should see why it's 0, which is like, well, duh. But anyway, you do that whether it's most likely you do that whether it's whatever method you're using. If they have something on their books that doesn't exist, you're probably going to look into it. But anyway, working the formula though, Projected value would be 0 divided by 1,700 is 0 times 40,000 is 0. Projected misstatement, 20,000. Incremental allowance is on the books for 1,700. It's less than the interval of, so there's still additional room in that interval. Am I spacing? So there's still room in that interval that other things could go wrong. So yes, it should be included in the incremental. All right, now for 4. 4 is unusual. Why? What's unusual about 4?
The audit value is more than the book value.
Yeah, this is an understatement. Oh, I don't know. yeah, this is an understatement. And because it's an understatement, they have it on the books at 1,900. We will look at it as worth 2,600. They've understated it by whatever 700. In that case, we say everything is okay. We ignore it. It's not going to be projected misstatement is 0. We're not supposed to find those, and when we do, we say there's nothing wrong. There's no problem. Incremental allowance? Nope, there's nothing wrong with it. We're not gonna nothing more in the incremental allowance because there's nothing wrong with that one. So that is if it's an understatement, we ignore it. And it doesn't matter whether it's bigger than the interval or not. If it's an understatement, that means that everything's okay. Now, down here is where we get to the tricky ones. And they're tricky for a couple of reasons. Okay, I'm going to do this incorrectly. I know you guys are used to seeing me do things incorrectly, but this time I'm going to do it on purpose incorrectly. So don't do what I'm doing right now. Don't do it. I'm going to pretend I don't know what I'm doing, and I'm going to put this in like we have been doing the other ones. So if I did this would come out to 0.25, it'd be like 10,000. Again, do not do that. I'm doing it incorrectly. Okay. Okay, so I would say, okay, this is 11,000 divided by 44,000 ends up being 0.25 times 40,000 equals 10,000. And so I'd say, okay, the projected misstatement is 30,000, right? Okay. So say, okay, well, what's wrong with that? Well, if you look at this one, so we're saying that the misstatement, projected misstatement from this is 30,000. However, if you actually look at it, what is the actual misstatement for that item? The audit amount is 11,000. The book amount is 44,000. What is the actual misstatement?
Is it 33,000?
Yep, perfect. Yeah, the actual. Is no, I'm sorry, I did it wrong. I'm still doing it wrong. So this is actually what we are going to use for the misstatement. We know that this is misstated by 33,000. It's more than the 30,000 if we do this method. So what we're going to do is not do any of these. And instead of that, we're going to say this is, this statement is 33,000. And this would be whatever, this would be 7,000. So this would be what we would use for. So if the item is larger than the interval, so the book value for that item is 44,000. Interval is 40. It's bigger than the interval. You do not multiply it out. You simply take whatever the error is, 33,000. Another quirk to this, because it covers the entire interval, it cannot get any worse. There is no incremental allowance. That $40,000 interval cannot get any worse. The entire 40,000 was taken up by this item. So there isn't anything else that could go wrong in that interval. So I think this is wrong off now. And that's because this would be actual misstatement. Oops. What did I goof that? And we'll do the same thing down here. This is, now this one, 90,000, this would have covered at least 2 intervals, may have covered 3, but it's the same as number 5. Do the same thing with them. So 90,000 minus 65,000 equals 25. 25,000. My little arrow. And we would not, oops, we would not include that in the incremental, because the intervals could not go more wrong. It covers the entire interval. Okay, the projected misstatement will be all of these. Well, you get the idea. So add these up, this will be the projected misstatement. So this would be our best estimate as far as what these are misstated by. What is that? 12. By the way, don't this one shouldn't be there. Okay, I came up with 118,000. So,
I got that too.
you get that too? Thank you. So this would be the projected mistake. So we're saying that bills are off, that the books are off by 118,000. Now, you may say, well, are these understatements or overstatements? They can only be overstatements because this method is not good for understatements. We get an understatement, we ignore it. So these are only going to be for overstatements. So we're going to take the book value of the accounts receivable. We'll bring it down here. I gotta fix the formatting of this thing. So book value minus projected misstatement. Again, we're saying it's this is an overstatement. What is that? $682,000. Oops. So we're saying that there's either misstated by 118,000. The accounts receivable balance was, where our projected balance is 682,000. And this would be our best estimate of what it is. Okay, so these are, and a lot of times when you see these problems, you'll see that they'll give you only the ones that are, in errors, because those are the ones that you're actually, the ones where everything is okay, those aren't going to give you any information, really. So a lot of times they'll only look at the ones that have a problem, and that's what you're going to use for your projection. Here's a question for you. How many items were in the sample?
Would it be 6?
Nope, more. I'll give you a hint. The interval was 40,000. The book value was 800,000. How would I put a dollar sign in front of that? Should be a dollar sign there. So how many items were in the sample? We know that it was broken up into $40,000 chunks, and that's based on how many items that were in the sample. So the question is, how many items were in the sample? Either shout out your answer, or you can even send it to me in chat too. Oh, somebody knows this. We'll sit in awkward silence. Play the toy car until you guys tell me. Yeah, play with the toy car. Come on, somebody has this. How many items were in the sample? The interval is 40,000. Book value is 800. How many items?
$20?
Yeah, I was gonna say 20.
Yeah. If oops. Okay, back to normal. Yeah, yeah, so there's 20 items. Now 6 of them had problems, so there was what, 14 that were fine. Actually, this one was fine too. So 15 were fine. Now, in real life, if you ran into the, I purposely make these a little more exciting than they need to be. In real life, you go through 200 of them, you find 3 items that are wrong. So to do that in a class would be torture, even more so than this. But the yeah, so if you were doing this, like, if it was a real audit, you'd probably be pretty discouraged by the results. But yeah, but this is basically how you do it. You get a projected value, and this is your best estimate. Okay. This is going to be a long time. Let's go ahead and take a break. What is it? 7:02. Let's get. Oops, that's not going on. Let's be back at day 7:10. And we'll kind of put it all together in the last in the problem 5. Problem 5. Okay, I'll put this one back up. And again, this kind of wacky stuff in here that's the problem. These are, well, that one too. These are just kind of what you'd expect down here. These are kind of the strange rules that we have. All right. Okay, so we're gonna come back and the problem number 5, just to let you know, it's basically what we've been doing. However, it's going to have sort of like on that in classical sampling, you have the bell curve thing. It has that, except that it figures it out in a little bit different way, and I'll go into that as we go on here. But we're going to start out exactly like we did. Okay. So so 8,000 divided by 10,000. I'm going to make this more online friendly next time we do this. I thought it was okay until I started working at it. All right, so we have 8,000 divided by 10,000. Turn on the calculator. Times 50,000 equals 40,000. Projected misstatement then is 10,000. Okay, is it included in incremental allowance? It is. The book value is less than the interval, and it is. So the book value is less than the interval. So yes, it will be an incremental allowance, which we'll talk about in a few minutes. Okay. Oops. I am doing crazy stuff here, but it's not on purpose. Okay, so $1,600 divided by 4,000. So we got the item. The item they had in the books for 4,000. We go look at it. We see it's worth 1,600. So 0.4 times 50,000. So the projected value is 20,000. So the projected misstatement would be 30,000. Right, so the interval is 50, 20 is misstated, and the rest will be in. Okay. Now, is it included in the incremental allowance? It is if the book value is less than the interval, and it is, right? This is less than that. So there still could be more things wrong in that interval. So yes, it's included. All right, how about this one? What do we do with it?
No misstatement.
Exactly. This is an overstatement. No, it's not. It's an understatement. I'm sorry. I'm saying crazy things. This is an understatement. We're not supposed to find it. And when you do find it, you just ignore it. So this one isn't a problem at all. Projected value would be 50,000. Projected misstatement would be 0. And no, it's not in there. And even if it were, it wouldn't be a problem because it's at 0. So you know, 0 times anything's at 0. Okay, so the projected misstatement would be adding all these up. Which, how do you do in your head? Okay, so 10 plus 40,000. That should not be red. So this will be our projected misstatement. And this is our best estimate of what is misstated by. Okay, now there's two things here that are completely new to us. Calculate the basic precision and calculate the incremental allowance, and I want to talk about those because they are so wacky. I ran out of new paper, so I got to use an old one. Okay, so it's sort of like this. In classical sampling, we had you get your bell curve here, and it looks like that. And we do standard deviations. So, you know, this is one standard deviation, this is two standard deviations. Anyway, so, you know, I say, okay, this is, you know, so for, in our example here, this would be minus 40,000. And it could go either way, one or two standard deviations. So that's classical sampling. The type of sampling we're doing, the monetary unit, is a little bit different. It still has the same idea as up there. You know, make it let's go over here. But basically, it's what they would call a one-tailed test, because we're not looking for understatements, we're only looking for overstatements. So it's really only going one direction. So this is minus 40,000. It's an overstatement, whatever they have here. Do I have it? I can't remember what I put up for that. So the 600,000. So this is 600,000. Oops, more zero. And then this is 40,000 less. But it could be worse. Remember, we're doing sampling, so just because we came up with this doesn't mean that is everything that could go wrong. Now, we don't have standard deviations. In this. We do have two other things, though, and we have one that is the basic precision, which I'll talk about. And two, we have the incremental allowances. Those take the place of standard deviations up here. So if we say how bad could things get, it's the 40,000. There's also a basic precision we're going to discuss in a second, and then incremental allowances. The basic precision is the amount that it could be off if there were, no errors. Remember, this is sampling. So even if we didn't find any errors, it could still be off just because it's a sample. The only way you can tell. So basic precision is if there are no errors that we find. We don't find any errors, it could still be off by some, just because it's a sample. Incremental allowance is if we do have errors, they will increase that amount that it could be off by. So the incremental allowance is for when we do have errors. So basic precision, it says, okay, if we don't have errors, and you might do a sample that doesn't have any errors, you wouldn't have any incremental allowance. You'd just have the basic precision if you didn't have any errors. If you do have errors, and they're the type of errors that go into the incremental allowance, then you'll have this, there'll be additional amount. And it matters how big the errors are. The bigger the error, the bigger the problem. Okay, so this is kind of the idea behind it. Again, we don't have standard deviations. By the way, looking at my writing, this is why my typing into the thing is probably better than. All right, so this is the incremental. The basic precision is if we had no errors, it could still be off by some. And incremental allowance is if we do find errors. They don't have to be errors in there, but if we do find errors, that it could be even worse, right? It could be even more off than it already is. Okay. Basic precision. Oh, wait a minute, I gotta do something. I chose the wrong thing. Okay. Basic precision. Go down to that table thing at the back. Equals the interval times the reliability factor. I'm going to go ahead and copy that. Okay. So what's our interval? . What's our interval?
$50,000.
Interval, it's here. It's- times our reliability factor, and that is, oops, up here. So our reliability factor now, was it 5%?
We're looking at the third one, right? So that'll be 7 times 6.
Well, the reliability factor now, here's the thing, for sample size and for basic precision, we use row 0. So we're going to use row 0 for our reliability factor and for basic precision. Now, if you think about it, basic precision is for when there's no errors. So that's why it's at row 0. If you didn't have any errors, that's what it would look like. So basic precision is, okay, we don't have any errors. The sample still could be off because it's a sample. So we're going to use the 5% at row 0. And again, for this one, it's because basic precision is if there are no errors. Three. Oops. Oh. And that equals
150,000.
Yep. Very good. So 150,000 will be our, wait a minute. 150,000 will be our basic precision. And again, this is if there were no problems. I'm going to put another space. Looks kind of fun. Yeah. So if we didn't have any problems, well, first of all, this one there would be no projected misstatement if we have any problems. Well, it could be too if they covered the entire interval, we wouldn't have any incremental allowance. But anyway, yeah. So this would be the basic precision. So if there's no problems, this could also it could still be up at 150,000. Incremental allowance. This is the wackiest thing you're going to see in your life. Maybe not, but it's pretty wacky. All right, and I have got to get the table up here. All right. Reliability factor increments times the misstatements largest first equals the incremental allowance. So the first thing we're going to do is find the reliability factors. This could be done so easily by making a table, but I'll show you what it is. At 5%, right? So 5%, we go to the reliability factors, and we say, what is the incremental factor from 0 to 1? Well, overstatement 1 would be 4.75. minus statement 0, which is 3.00. Oops, I'm doing O's. Minus 1. The one in this formula, I'm assuming is for degrees of freedom, most likely. That equals 8.75. So this is our first reliability factor increment. Now, you're probably saying, well, can't they just make a table that would have that? Yeah. If I ever write an auditing book, I'm going to make a table that just shows the, this is the incremental. It'd be easy to make a table that just showed the incremental for each one of these. But we'll go through. Okay, the next one, overstatement 2, which is 6.30. Minus overstatement 1 is 4.75. Uh, 630.
0.55.
Okay, well, so 155 minus 1 should be what, 50.55.
Point.
All right, so that would be, well, let's make it a color. This would be so easy just to make an incremental table. And number 3 would be the same idea. 7.76. Minus 6.30. Oops.
Point 46.
0.46.
Yeah.
Thanks. Okay, so we find the reliability factor increment. So we just did here. This is 0.75, 0.55. Okay, I'm going to get rid of this table now. Thankfully, we're done with that. Okay, so now you multiply by the misstatements, largest first. So we're going to take the 0.75 times our largest misstatement that we have up here, which is Our largest misstatement is 30,000. So 30,000 is going to come first. So we take the biggest misstatement first. Whatever that is. 22,500. I better multiply it out. So 30,000 times 0.75. 22,500. Coming down here, the next biggest one. .55 times 10,000, and that's the last one. Actually, we're not going to have a third one because this is I was misstated. This would be 10,000.
$5,500.
Yep. So this would be the incremental 2, and notice that the larger that these numbers are, the more it's going to, the larger they are, the more the incremental allowance is. If this was $1,000, it would be much less, and so on and so forth. So the size of the error matters in this. So the incremental allowance, we don't need that one over there. So this will be uh, 28,000. I want to check that. Oops, we need more zero, don't we? So 22,500 plus that. I think that's 28, right? Yeah. All right, so this would be 28,000. Excuse me. So this would be an extra layer of things that could go wrong because we had these errors, these $30,000 misstatement and the $10,000 misstatement. So that indicates that there could be more things wrong. Sorry about that. I have a little stool on my desk that I think is only there for me to put my knees on. All right, so this, all three of these together. So this is our best estimate as far as what the books are off by. However, just being this is a sample, we got by another 150,000, and that's if there weren't any errors. And down here says, okay, there were some errors, which indicates that there could be more things off. An error indicates that there could be more problems, and the size of the error matters. You'd hope that the internal controls would find an error of 30,000 or whatever. So the larger the error, the more allowance you're going to give for this incremental allowance. Small error, small allowance. So the upper limit is I have got to fix the formatting on this thing. All right. So it's going to be, our projected misstatement which was 40,000. And this is our best estimate as far as what it's off by. Best estimate of this statement. Okay. We're also going to have our okay. Our basic precision. And this is the error that could be there, even if there was the misstatement that could possibly be there, even if there were no errors. And then we're going to have the incremental allowance. And the incremental allowance is basically when there are errors. So basic precision is the no error problem that you have. It could be off by more, even if you don't have any errors, just because it's a sample. And the incremental says, okay, if you have errors, it matters how big they are, and obviously how many you have, but the size of the errors matters. So this will be an additional 28,000. All those together. Whatever that is. 40. 18,000. Now again, I made this a little more exciting than I probably needed to, but so this would be the upper limit on this statement. So that is how bad it could get, and this is what you'd use to come up with your estimate of what it's worth. Now, I should probably make this a different number. 600,000 is really low for what we just did, but so you take 600,000 minus that would be the. We'll go ahead and do it. Copy it. When I remake this one, which I'm definitely doing because of the formatting. If I use like 6 million or something. Oops. And so this would be the projected value. Actually, no, that won't be. It'd be projected value minus the upper limit. In other words, it'd be how bad it is. So at 382 something. Like that. This is. And again, these two are sort of like, they sort of replace the standard deviation. This is okay. This is our best estimate, but things could be worse because of these two things. Questions on that? Okay. I'm going to talk about this one in a second. I think I'll give that one to you as homework, I think. But let's go down here. I just want to talk about the pros and cons of it. So this is the second to the last page, I think. And this just kind of compares both of the methods. The monetary unit sampling, big advantage. If they don't have very many misstatements, you can usually get a smaller sample size. And this is huge because sampling is what really takes a lot of time, costs a lot of money. And so if you can get the same level of precision, if you can get the same level of comfort, say 95%, with a sample that's half the size, well, that's huge. We talked about this, I think, last week. Automatically stratifies the sample. Larger items are more likely to get picked. Remember back to page 1. Larger items are more likely to cross the interval, so they're more likely to get picked. Oops, too far. And usually it's easier to use than classical sampling. I know it doesn't seem that way right now after we jump through all these hoops, but it really is it is much quicker. Everything about it is quicker if you compare it to classical sampling. Disadvantages, big one, cannot be used for understatement. So things that are understated, things like liabilities or expenses, not good for them. Sample size is not easily expanded. If you come out, there's a problem, and to expand it to say, okay, let's be more sure, is really hard to do it. You better off usually just switching over to classical sampling. Okay, classical sampling. So this is monetary unit sampling. Classical sampling, the one we did before, that's the mean per unit and all that kind of stuff. This is the, you guys remember this. This is, those things, remember we did those. Okay, me hitting my stool again. Okay, this is if they have a lot of misstatements, classical sampling is fine with it. Classical sampling has no problem with misstatements. It simply, it'll average out the overstatements, the understatements, and all that. It has no problem. Items with negative balances not require special consideration. Usually you won't have negative balances in anything, but I guess if you did, it wouldn't be a problem. If you had a negative balance in, say, accounts receivable, it's really an accounts payable. So usually you don't have negative balances. I'm not sure why that would be somewhere. This is the real beauty behind this one. Can be used for understatements or overstatements. So if you don't know whether it's overstated or understated, this is the method to use. And sample can be easily expanded. So if you get a problem at, say, the 95% level, you can keep going, test up to the 99% level. Not a problem. You got to estimate the standard deviation. This is the problem. That can be kind of a hassle. And the stratification may be needed. And stratification is, you recall doing that. Stratification is like, you talked about a long time ago. Say accounts that are over 10,000. Maybe you test 100% of those. Give accounts 1,000 to 10,000. You test 40% of those. And accounts say under 1,000. You test 5% of those. So that's stratification. Oops. Okay. Don't have to do that in the monetary unit because it automatically does it. Okay, so this answers disadvantages. Okay, so I think I'll give you number 6 as homework, but I want to talk about these. If there's going to be a problem, it's going to be probably with these here. So this first one, what do we do with this one?
Understatement. There is no misstatement.
Good.
Understated, sorry. And no misstatements.
Exactly. This one's an understatement. So it looks like I have a problem. This one is just run of the mill. This one, what's the weird thing about this one?
The book value is higher than the interval.
Yep. So you simply take the misstatement for the item itself. So 108 minus 95, whatever that comes out to. You don't have to do all the multiplication stuff. This one, no problem with that one. Okay. Well, this first one, since there is no misstatement, what would the incremental, would it be an incremental allowance?
No.
No. All right. Let's see here. And by the way, even if there was, if you multiply anything times 0. All right. This one, would it be an incremental allowance?
Yes.
Yep.
Oh no. Which one? Second one? Yeah.
Yep. This one would have an incremental allowance because this is less than the interval. So there could be more things that go wrong in that 100,000. This one is a no because nothing else could go wrong. It covers the entire interval. And this one, it's smaller. There could still be more things that are wrong. So this one would be a yes. So you're going to have 2 in the incremental allowance. You're going to have 3 errors. This one, and this one. The last 3 will have errors. This one, no error. Just no misstatement, probably a better term. Because this is a it's an understatement. And this method is not supposed to catch those, and when it does, this ignores them. Kind of childish, but so these 3 will have misstatements. Oh, I didn't, wait, hold on, I didn't do this. Two of those will be an incremental. So you have 3 misstatements. These 2 will be an incremental. This one will have a misstatement, but it won't be in the incremental. It'll only be up here. Okay, so I think next week we'll go over this one. So give it a shot, and don't be afraid to make mistakes at it. So just do this for next week, and we'll start out the class looking at this one. So I don't know what page it's supposed to be. Is it on page 5? I don't know. Probably number 6. So problem number 6, we will start with next time, and yeah, give it a shot. I think, hold on a second, camera here. No, I think I gave you guys the exam, and it's due on Saturday. I think I made it on Saturday. I gave it to you guys a day late. So it's due on Saturday. If you have any questions on it, feel free to ask. My office hours are tomorrow. They're usually at noon and 6. However, I won't be there at noon. My wife has a doctor's appointment. But anyway, so I won't be able to do the noon, but I will be there at 6. And if you have questions, you can email me, or and we can set up a time. Or if you have any questions, you can put it in the email, or however you want to do it. It's fine with me. I don't mind making if you want to set up a Zoom meeting or something like that, that's fine. It does not have to be during the office hours. There are 2. I don't know. I don't think the tutors would help you too much on this stuff. So it's kind of wacky. But yeah. So if you have any questions on it, let me know. And either on this the monetary unit sampling, or on the exam, if you have questions, you want clarification on something, you can feel free to ask me. I won't give you the answer, obviously, but we can go over exactly what it, what's in the questions. Any questions?
Professor, can I see the end of problem 7?
Absolutely.
Please? Thank you.
Wait, 6? This one? Or the one we just did?
The one we just did. Can you share your screen with us too, please?
Yeah, I'm sorry. It's like a bad ventriloquist act. So do you want where do you want to go on? Up?
No, I think it's problem 7, just the disadvantages part. I didn't get the end.
Oh, I'm sorry.
Yeah.
Let's see if I can get this.
Can you keep going to the disadvantages? Yeah, right there. Thank you.
Okay. Yeah, and the stratification, that you usually do that because the bigger ones are more important. And again, the nice thing about monetary unit sampling is you don't have to do that. And not only that, it calculates it by, it's 1-to-1 for the dollar size. What I mean by that is something that is $1 versus something that's $100. Whatever's $100 has 100 times more likely to be picked than an item that only has $1. So it is exactly proportional to the dollar size. So it's a really, it's a curve. My hands are on the screen, but it's a curve, of the more. Actually, it'd be a straight line. The more likely it is to get picked is based purely on dollars. So that's why it's called probability proportional to size. Proportional size means a $100 item is 100 times more likely to get picked than a $1 item. It's proportional to the size. And a $10,000 item is 10,000 times more likely to get picked than one that's $1.
Can you show the end of question 5, like towards the end? I missed this little part. Yeah, that's it.
Yeah, and this is the way, this would be so easy to make a table for these incremental allowances. I'm not sure why they don't, but and I've never seen a book that had. I've never seen an auditing book that had those in it. So I guess they like that, that little bit of work or whatever you have to do. But it would be so easy just to make one more table to have the incremental and just say, okay, multiply by this, multiply by that. I bet you money that the CPA firms that use those would probably already have that. They're not going to have you out there in the field trying to figure out what the incremental is. Multiply it by this. Go on to the next thing.
That's it. Thank you.
Any other questions on this thing? And I realize it's a lot. I mean, this is you will not see anything like this in your statistics class. It's completely focused on auditing. It's only for us, basically. It's very effective in certain circumstances, and it's a smaller sample, much easier to catch fraud and all that kind of stuff. But it's a little bit quirky, but it does work. I mean, a few things here we could probably clean up and make it a little more mainstream, but anyway. All right. Any more questions or anything else you want to see? All right, and this, yeah, so on this down here, these are the ones that are going to have misstatements. The first one will not have a misstatement. It's an understatement, and we're only looking for overstatements in this method. So it's like going fishing and catching a boot, and you don't throw the boot back in the water. You probably throw it in the garbage can. But the idea is that that's not what you're looking for. You're not going to keep it. Okay. Well, I will talk to you guys next week, and or earlier if you want to set up a meeting, or at 6 o'clock tomorrow. And give this one a shot, and don't be afraid to make a mistake.
Thank you, Professor. Have a good weekend.
Thank you.
Okay. Yeah.
Have a good night.
It's supposed to be nice this weekend.
Oh yeah, it's supposed to be 60.
Yeah. Oh, wait, what am I doing here? Oh, I didn't. Okay.